This video is to go over building Java programs, chapter 17, which is about binary trees, and this is tree traversal. There are three ways to traverse a tree, and there's an incredibly simple way to do this. It almost is shocking that it actually works, but it does. It's very simple. Imagine yourself as a little boat traveling around these islands. Okay, if you want the pre-order evaluation, what you're going to do is travel around here, and whenever you see a boat on the left-hand side of a node, you're going to write it. So we're going to start with the boat travels down here. It'll see a 3 and a 5 and a 1. Let's start with that. Then the boat is going to come back up here on the right side. It's going to come down this side. Now it's going to see 2 and 4. Okay, so let's add that. Then as the boat comes back around here, it's going to see a 6. And then finally the boat's going to travel on the right-hand side of all these, but it's already seen them all. The in-order traversal is the same boat travel, but we only report things when we are at the bottom of the island. So we go past 3, past 5. Only when we get down here do we start recording it. So we're going to record 1, 5, and then 3. Then that boat is going to travel down here. It's going to see 4, and then 2. Then that boat's going to come down here, and it's going to see 6. And then it's going to come back here, but there's nothing else to see because it's already seen all these items. The last order, called post-order traversal, is we're going to follow the same boats, but now we're only going to report them when we're on the right side. So here, we're going to report a 1 and a 5, but not the 3 yet. Then we're going to come down here. The boat has to be on the right side of these, so it's going to be 4 and then 6. Let's write that down. And then it's going to come up and then 2 and then 3. And that's all the correct tests. Now you should probably rightly wonder, why do we need to learn these different traversals, and what do these traversals mean? Because obviously in this example it's pretty meaningless. The reason why we learn these traversals is because in recursively dealing with binary trees, this is it's a representation of how your code is going to behave depending on when you evaluate the subtrees. So let's try to think of a good example for this. I've dropped into Paint here in order to show you some more detailed examples. I didn't really like the examples they were giving there because it was pretty meaningless. So one of the assignments that I give my students is to do an expression evaluator. So something as simple as 2 plus 3, that is, it's very common for us to look at this. We know it. We don't think anything of it. But actually, there's 3 different ways to evaluate an expression. There's what we call this normal way, 2 plus 3. There's also a postfix expression, 2, 3 plus, and this is what used on reverse Polish notation calculators, your HP calculators, and this is the actually easiest way to do things. And you'll find that many professionals in science and math use reverse Polish notation because it's 100% clear. You don't have to worry about any parentheses. There's also you could do prefix, so you could do plus and then 2 and then 3. So let's take a look at example in a binary tree representation of what this looks like. So the operator is going to be plus, and you've got 2 children, 2 and 3 here. These try to make little boxes around here connected by lines. So this is what all 3 of these expressions would be stored in a computer in a binary tree, probably like this. You want to have your operator with children as your operands. So let's take this type here of evaluation. How do we get 2 plus 3 from this binary tree? Well, we've got to traverse around this tree, and we want to get the 2 here, we want to get the plus here, and the 3 here. That means that we need to do the in-order evaluation. Let me see if I can undo those marks. I can. So if I want to do it this way here with reverse Polish notation, what will I want to do? I want to be able to get the 2 first, and then the 3 first, and then the plus afterwards, which means I need to do postfix evaluation. I want to get it 2, 3 plus like that. And then finally, for the prefix implementation, what I want is I want to evaluate, I want to pull it off on the left, on the left here. So how does this translate into code? Well, it's just a question of what your code exactly does. So when you're um, crossing this binary tree, you get to choose when to operate on things. So depending on which way you're going to do it, pre-order, in order, or post-order, you can operate on things at those various different points. So when you start writing the code to do these traversals, you'll see that depending on whether you do pre, in, or post-order, you get a different way of evaluating things. So that's the reason why we have the 3 different types of evaluations. If you found this video useful, please like and subscribe.